Welcome to springlib.
We're asked to find the shortest possible length of the line segment that is cut off by the first quadrant and is tangent to the curve y equals 3 over x at some point. So we have our function y equals 3 over x. We want to find the distance between the x and y intercepts of the tangent line to the curve at some point. So the derivative, y prime, this is negative 3 over x squared, which is our slope of this line. An equation of a line that passes through the point A, 3 over A, with this slope is y minus 3 over A equals our slope, negative 3 over A squared times x minus A. We can expand this to y equals negative 3 over A squared x plus 6 over A. Now to find the y-intercept, we simply set x equals 0. So I have a y-intercept of 0, 6 over A. Find the x-intercept. Well, this is setting y equal to 0. And this gives us the point negative 6 over A divided by 3 over A squared, which is just 2A, 0. Now the distance from the x-intercept to the y-intercept as a function of A, I'll call it d. This is the square root of the difference of x-coordinates, which is 2A squared, plus the difference in y-coordinates, which is 6 over A squared. Now, we know that this distance is minimized when its square is also minimized. So we have our function f of a, which is 4a squared plus 36 over a squared. Now we want to minimize f. So we'll differentiate and find where it's 0. F prime of a is 8a minus 72 over a cubed. And we set this equal to 0. Solving for a, we get that a is equal to, eventually, the square root of 3. Notice that the second derivative of f, this is 8 plus 4 times 72 over, this should be 3 times 72 over a to the 4th, which is positive for all values of a, including a equals root 3. Therefore, it follows that our function f has a minimum at a equals root 3. Of course, by our previous discussion, this is also the minimum. D also has a minimum at a equals root 3, and so our minimum distance is going to be d of the square root of 3, which is the square root of 4 times 3 plus 36 over 3, which is the square root of 12 plus 12, or 2 root 6. And so the shortest length is 2 root 6, which is approximately 4.899.